So, yeah, then let's go for the presentation. I mean, this was a quite maybe unusual, intensive preparation for the presentation, but I think it's during setting the scene for this workshop series, it's good to have some impression what we talk about. And of course, later on, I mean, we change a little bit the activities also. That is what Bastien has also shown. We will go more into, let's say, science than what I do. But to give a little bit framework, I think I start here today, and my outline is, by the way, can you see? Do you also have this black box via above my headline of the slides, or can you read outline here?
Yeah.
Okay, because I have then it's only my screen maybe that there's this control of this of Zoom. Some parts of myself. Yeah, maybe about myself, what I'm doing, why I'm now the regional coordinator of the Eurofriend part. We speak about the Friend Water Program and Eurofriend in particular. I will give you a guidance and some information about available global water data, and I will give you an impression on an idea, concept, outcome from a research project, how to bridge the gap from data, from observations, but also from modeling to a big audience. And yeah, as Bastien has kindly said, I'm from the International Center for Water, Resource and Global Change. Not sure if you do not know that one. This is a Category 2 center under the auspices of the UNESCO. And that is our website. So what you see here, we are active in research. We are working with data. I will come back to that later, but also in education. And if you are interested, please visit our website, and here you can also register to our newsletter. We are not alone. There's a whole family of similar water-related data or centers, what called UNESCO Category 2. Category 2 just means for UNESCO they are not paid on the payroll by UNESCO itself. That would be Category 1 centers, but they ask different governments if they don't want to host such a center, and in my case, Germany is paying our salary, let's say, and there's some around, and they are all active in different with different background, with different objectives, but in general they do research. There's a support research. What we here also do is give some support of operational global data centers. We are active in capacity development and training like today, but also really capacity development in the fields, and we contribute here to IHP programs and strategies by UNESCO. If you look a little bit of our history, so we were already founded in 75, not as an international center for water resources, but we have a background. There are this water science programs by WMO, by the World Meteorological Organization, and by UNESCO. And the secretariats, those have most commonly national secretaries, national committees, maybe also in your countries. And yeah, this one is how we were founded, and we were always located at the Federal Institute of Hydrology in Koblenz. And since 2014, we were founded as a UNESCO Category 2 center. And since then, we also host, together with the BFG, the World Water Quality Data Center from the Global Environmental Monitoring System of UNEP, with a database of GEMSTAT. We coordinate since 2017 the Global Terrestrial Network of Hydrology. I will come back later to that. And since last year, we are on the transfer of another data center together with the BFG. This is the International Soil Moisture Network, and this is developed by the colleagues at the TU in Wien, and we will And I mean, that's kind of a research project funded by the ESA, and we do now the operationalization on a long-term perspective, some things what universities usually cannot do. And since 2022, I'm the regional coordinator of Eurofriend, and I shared this together with Henny van Lanen, who were active since a lot of years in the community of Friend and Friend Water. And I don't know if he's here, and I don't see every participant who also wanted to join, I guess. So Henny, if you're here, good to see you. Otherwise, we will see at another point. Yeah, Friend Water Program. This is it's a UNESCO it's a flagship initiative by UNESCO, and it's one of the oldest ones. It was founded already in '85, and FRIEND stands for Flow Regimes from International Experimental and Network Data. And one of the ambitions was really to go into the field and use the scientific communities to collect data, to provide data, with the idea of course, to analyze them and doing some hydrological research on it. But the data exchange was really one of the major objectives, I would say. It contributes to climate change, risk analysis, decision-making in depth on river basins. And one of the last publications which we have was from last year. So you can go to the proceedings of the International Hydrological Society, and there you find this publication. I also shared the link here. And on the right-hand side, you see a map of the global map. And the greenish one, that's the Eurofriend area, so northeastern Europe. And then next point is, what guides, if I've said Friend Water is kind of a UNESCO flagship initiative, so, and we somehow contribute to what are the wishes of the Intergovernmental Hydrological Program. And here we started, or just entered the new phase. So IHP has always phases, and we are now in the phase 9. And this has 5 priority areas. One is scientific research and innovation. The other one is water education, bridging the data knowledge gaps, and others one are more about integrated water resources management and water governance. But in particular, the first 3 here is Friend, I would say, active. And if we look in some of the official documents, the link is here also below, they also said, okay, one proposed activity for Friend is a maintenance, consolidation, expansion of existing hydrological networks, the network data. And here GRDC is mentioned, and Friend Water databases, as well as eco-hydrology demo sites. And this is something which really points back to the spectrum which I have shown from 85, and I'm not sure, and this is something what we have to elaborate a little bit, if this is really our key activity, what we still do today. But if you look at the, that is now also just a quite new publication from 1st of April this year for the next Intergovernmental Council. So that's now on a UN level, maybe not so interesting for you. If you're interested, please let me know. I can give you some more information, of course, about this. But here's about the program implementation of IHP Phase 9. And there you find this table, and here are thematic groups about eco-hydrology and experimental basins, about hydrological processes, and about climate change and risk analysis and so on. And you see again, a Friend is suggested to set it with all this broad network, and you belong to this network, contribute to those overarching questions, research questions, but also they should lead to kind of, let's say, operational implementation or behavior then from the governmental side. And Eurofriend has also 3 different research themes, or at least 2. One is the European Water Archive. This is grayish because in 2014 there was a decision to freeze the European Water Archive and to use instead GRDC portal to access the data. And this is why we always in friend collaborate, of course, with GRDC, which is one of our main data facilities. We have a project about low flow and droughts, which is headed by Kerstin Stahl, and then large-scale variations in hydrological characteristics. This is what, the framework for our session today. And our engagement is, as I've mentioned, to contribute to different priority areas of IHB9, but this is also, we want to link Eurofriend activities with other UN activities from WMO, from the UN Environmental Programme, but of course as well as from universities and research institutes in Europe. But we want also to reach out and do some capacity development also, let's say, in the global south. And therefore we have this global network with also different friend regions to do that. And one major thing where we want to work about is about addressing this gap between information and knowledge, and to bring in here some tools. And if you talk about open science, or open science in hydrology, this is of course one of those aspects what we can do if we speak about this process of bridging the gap between data and observations and really knowledge. Then there are a lot of steps necessary, and here are just some, let's say, keywords which you see here. The second talk in this workshop series by Thomas Recknagel is also going into this field, and he will talk about reproducibility, for instance, and using some concepts here, using R as a development framework, and will show you some examples what we talk about. But this is clear. If you do science, we also want to reproduce them. That is also the reason why we have to share the data. I mean, that is what the journals are requested for. Please put your data on public repositories, that your research can be reproduced. And reproduction is, of course, not easy. I mean, just sharing the data doesn't allow for reproducibility. You need the recipes, kind of your algorithms, what you use for data analysis and so on. And that should be portable, that should be readable, that should be traceable. And if we speak about sharing data, traceability is also really important, of course. If you have your own, let's say, observation network which you do with your lab at the university and maintain it for years, maybe decades, and you share the data, data will be shared with public repositories or larger repositories, and then of course you will get cited. Your data, your work should get cited. This is via traceability, and to bring that all together, you need a good documentation and so on. So a lot of overhead is at least necessary to really work in open science and hydrology. And openness, transparency, collaborative cooperation. I mean, there's a lot of open stuff around. We speak about open data, open research, open knowledge, all the other open things. And this is also quite formalized, let's say, or there are large communities behind it. Open source initiative is more working with software development, all this, maybe some most well-known ones. For scientists, of course, also open access is quite well-known to ourselves. Open educational resources, I mean, that is something which might be new to you. This is a really concept by also supported by the UNESCO, and with this workshop series we will also want to go this way to publish this presentation here as open educational resources so that we can reuse it. And to make that clear, I mean, that is why in particular here, I also not gave the names and of the authors about this different icons, but I'll also give ideas or information about the license they have used. So for open educational resources, but also for other open things, you need open licenses that everybody else can learn and know how and under which conditions it is allowed to use the data, the information, maybe to merge it with others, to republish, to reuse it. And then we have open science. This is also from last year. There was a big step for UNESCO. There was a recommendation on open science. And if we speak about data, open data, we have a lot of open data policies around. And WMO, for instance, is working now on a unified data policy that also the big data centers and national authorities are invited to share hydrological data. And this is, of course, something which is not the case up to now. And this is something on a high political level, which we have to work on, but also on a scientific level, you should know that it makes sense to share data. And not only observational results, but maybe if you apply and maintain observational networks, please share the data. They are really useful for others. So the next part of the presentation, so we go now to the available global water data. This is now just a figure about 4 of the data centers. From GPCCs. This is a global precipitation climatology center. Here are some data from the Nile, which you see on this Google Earth map. But you see also on this Excel graph, say some of observations or of stations who deliver data to the data centers. And you see here in the 90s and the early 2000s, the peak of data, and then you see a drop. This means we have really an issue with timeliness. So most of those global data centers provide quality improved data, and this is done by the original data providers, and so original data providers are not instances like the GRDC or the GPCC. They collect the data, they harmonize the data, and provide them with harmonized data products. So that is a reason, and this is a typical figure for most of the observational networks I will speak about. Then you see different examples from soil moistures, from GRDC, and from water quality. And for some of them, I will dive a little bit deeper into details during the next slides. But first, here's also an impression about the observations in hydrology, which are shared if we look at near real-time observations. So really from the different watering stations, let's say the discharge data, in which countries, and those are the blue ones, are those data shared operationally near real time. And in comparison, that's figure A above, you see this in context to meteorological observations. So this is a typical figure between hydrology and hydrological science, much more catchment orientated, let's say, in historical reasons, not so really aware of the benefit of sharing data. And the methodology. But if we speak about the aim of Eurofriend Project 3, here we speak about large-scale variations. And if you do collect data in your own catchment, let's say your own basin, that might be, of course, relevant for process studies in your catchment, but for other research, like really getting larger pictures, it's of course important that also those colleagues can reuse, analyze your data and outcomes, of course, after publication somehow. Yeah, and now just a I will give some impressions about the status, and also put the links to it where you can get the data. First one is, of course, in this context of Eurofriend, here's a GRDC, and as mentioned, Uli Lohse, head of GRDC, is here with us, and one of his colleagues, Thomas Recknagel, as well. Yeah, European Water Archive, this is a figure in the middle, is quite outdated since it freezed in 2014. But if you look now on the right-hand map, this is a new data portal of the colleagues here. And they provided in 2020 a new data portal. And what you see on this graph is a number of requests, about 30 years of operations. So it's really operating since 30 years, and they really highly improved with the new technology their system in 2 years ago. And you see this, really. Magnificent step forward to operations and to really bring data to the people, to you, which are doing the research and the analytics with it. And here just some stats what fields are working with this data. So you have a quite good global distribution, which is also well balanced, I would say. If you look at the left-hand bottom figure, subject matter, it's climate, it's hydrometeorology, it's regional hydrology. Working sector is mostly academic and research. And they also provide different export formats, which you can use. So they also have NetCDFs, for instance. If you're a modeler, maybe this is an important format for you, but they also provide kind of SD data or CSV data. Another network, this is the International Soil Moisture Network. Also here on the right-hand side, you see the link. Yeah, they have not so many data as GRDC. They're really quite new. And but here you find also in situ data for calibration, validation, but also for analysis of soil moisture, if you're interested in this one. And as I've mentioned, we are right now in the transfer to the potential transfer this project. It has been started in 2009 as a really student project funded by the European Space Agency, by the ESA. And at one of the panel meetings now 5 years ago, the colleague said, okay, we have really problem with maintenance and really looking to a long-term perspective. Since we are university only, our mandate is doing research, and they have founded this ISMN for calibration, or for the development and doing research on calibration and validation of satellite signals on soil moisture. And so we started negotiations with the German government in 2018. We also asked other countries, but in the very end, only Germany said then, okay, we will do it in the very end. And yeah, since then we are in the transfer of the ISMN. And again, I mean, here's just invitations. This is a more research network up to now, collecting more networks. So if you want to share soil moisture data, please, and you want to make them globally visible, so please contact us at ismn@bafg.de. Another network also relevant for this community here is about water quality. This is a global freshwater quality database GEMSTAT by the Global Environmental Monitoring System of the UN Environmental Program. And this is also hosted at our center here together with the BFG. The same is the reason for the ISMN. And yeah, here you have an international data source for water quality data. And what I want to show you here is the data architecture, because I mean, I selected here one of the most complex scenarios, because let's say collecting more reduced data set, let's say like precipitation or river discharge and also soil moisture with more or less, let's say, really a few variables only you will publish via such databases. But the water quality database, of course, I mean, has an issue that they speak about physical parameters like water temperature, like oxygen things, but also on different species of chemicals and also biological issues. And so they have a really big bunch of different parameters they have to deal with. But what you here see on the left-hand side, I mean, that's kind of a typical process. Data providers will share data in different formats, SQL, text, docx, Excel, whatever, with the database. They check it for integrity, they check it for quality, and then it comes to the data into the database and can be published afterwards. And those were only due to the scope of time, and at some point it might be also be boring to you. I mean, that's just 3 of the data centers which we have for if you look at global observations. We have this network of global water data centers, and here in this sphere you see names like GRDC and others. And this is a joint project by the WMO and by the Global Climate Observing System to bring those data centers together. And you can go to the website, GTN-H.info, and here you can also find links to all the other databases. So if you're interested in whatever in anthropogenic water use, you will find the link for the FAO Aquastat website, for instance. If you are interested in isotopes, you can find the link to the global network of isotopes in precipitation, or the global network of isotopes in rivers, for instance, and others. So please go there if you look for data, and you will find the relevant information. And what we are working right now on in GTN-H, I mean, that is something where a service, because at the very first glance, we don't know what terrestrial water observations are available. Of course, you can go via the GTN-H website and to look at every data set, what is available. They are quite well known. But what we need is kind of a discovery platform to have a one-stop shop set to show you the observational metadata in one stop. And that is our vision, what we want to achieve. In the next time, you see an example from the ocean ops community, which is something similar, I would say, for the ocean observations. And therefore, gladly GRDC colleagues, in particular Thomas here, is building up a kind of a pilot for such a discovery platform, and we'll see how to make use of it and what we need for resources to implement it really as an operational service. Because, as I've said, coming from a research project or development project, you always need, of course, resources, you can imagine, to have it on an operational level. And last section is a short introduction about a kind of climate service. This is from a project which was called COMIC. And COMIC stands for Co-Development of freshwater-related hazards in climate change. So this is a portal where you can assess on an easy way climate projections for hydro with a focus on hydrological indicators, hazard indicators. So what we see here is it's a knowledge portal. You see also the link again here. You can go there, and you have a knowledge portal, and here you learn what types of information offers this portal, why is this portal of interest to maybe your purpose, and how do you use the information in this portal. It's as I said, for climate projections, this is helpful. It uses 96 ensemble members in total, and those are derived from different RCPs. from different 4 different global circulation models, from 3 different global hydrological models, and each of those were calculated with different variations. And derived from that, there were hydrological climate variables derived and calculated, and also here are some climate impact indicators developed, like groundwater recharge, water productions, things like that, water availability, some indicator for water stress, and so on. And it has a global coverage. And the idea of the multi-model ensemble is also to say something about uncertainty of the future. And it was co-designed with expert stakeholders from different backgrounds. So we had a lot of participatory workshops with different colleagues, and we provided something what we called puny methods. So this is how to utilize the data of this data portal, because one relevant thing is the resolution is quite coarse. So 1.5 degrees resolution is for local assessment, of course, quite large, but we gave some introductions or some information how to really use it also on the local scale. And if you go to the portal, you can select an indicator, you can select what ensembles you want to have, and ensemble values like medians, like maximum, minimum, whatever. You can have a look at the global coverage, as I said, with a quite high resolution of 0.5 degree. But you can also look at the temporal resolution. We have time sliders here, and that you can move around between the next 100 years with, compared to the reference period 81 until 2010. And we use this what you call raster cell box, where you can assess time series or box plot plots or whatever. And with this, I will close just to get summary. So what is needed to bridge the data knowledge gap in hydrology? We have to improve the data exchange, and we have to apply for open data policies to really exchange the data. Then the research communities are needed to analyze data and to produce knowledge, maybe also data products. And then the last thing is we need to operationalize scientific results and products and put them maybe in services, and that might be also kind of national agencies or whatever with the power to provide such services on a long-term perspective. But here the circle is closing, because again, you will need their data again for your research. So, and this is really a circle of the systems, but in a process that we want to improve the system at all. And yeah, I will close the presentation just with a reference to David Skeller, and he speaks about interoperability, but I mean, this is true for this entire, let's say, value chain. That interoperability seems to be about the integration of information. But what it's really about is a coordination of organizational behavior. And that is what I want to show you on each level. So really starting at university, at labs, how to deal with data, but also large scale global data infrastructures and beyond, also to the politics. We have everybody has to work, and I'm optimistic here right now, I would say, to share data and information, and this is one, and to really make use out of it, and to reuse data and information. And with this, I would like to thank you for listening, and I only have a very last slide. Thank you for your attention.